Hi, my name is Juan Manuel Ramírez de Arellano and I will be presenting this poster for the Symposium A4 Advanced Catalytic Materials, Nano and Bulk within the International Materials Research Conference 2022. This is the general title of the work. As you can see, we are focusing on the surface of a bidimensional material that is called molybdenum disulfide, and we used ab-initio density functional theory calculations. We mainly focused on relaxations, geometrical relaxations, exploring the possible effect that a platinum atom had on the absorbing properties of this bidimensional material. So basically we explored the interaction between this material and three different molecules, as you can see here: hydrogen, carbon monoxide, and carbon dioxide. We calculated their interactions via structural relaxation calculations, and then we calculated its adsorption energy following this expression. The first case was the interaction between the pristine surface, the no defect surface, and just for a more detailed account, the unit cell in this case consists of 12 atoms, of which we have 4 molybdenum atoms and the rest are sulfur atoms. And this is a small unit cell, so that the calculations are not very long, but it's not that small so that we wouldn't have any spurious interaction. So it's sufficiently big so that, considering the fact that we are using periodic boundary conditions in the software that we considered, then there is a sufficiently long distance between repetitions, for example, of this molecule and the molecule in the repeated cell. So there is a sufficiently long distance between repetitions, and we can be sure that we are focusing on the interaction between the molecule and this substrate. So in this first case, we found only weak interactions that we could catalog as adsorption, and in the case of the hydrogen molecule interacting with this surface, we have here an absorption energy of 0.06 electron volts. For CO, we have a slightly larger energy of 0.11 electron volts, which could be considered as adsorption. And finally, for CO2, we have an absorption energy of minus 0.15 electron volts, which could also be considered as adsorption. We placed the molecules in the three cases over one sulfur atom, and that was because in the next case we removed that sulfur atom, and creating in that way a sulfur vacancy, also labeled V sub S. So this creation of the vacancy, which experimentally is sufficiently easy to generate, has a small catalytic effect in the interaction with the three molecules. As you can see here, when compared with the first case, we have a slight increase in the adsorption energies, a very tiny increase. For example, in the first case, we have a very tiny increase of 0.02 electron volts with respect to the first case, and so we have something similar for the next two cases. And finally, we let a platinum atom interact with this substrate, including the vacancy, and we found that the platinum atom was chemisorphed at the vacancy site with an adsorption energy, a rather large adsorption energy of minus 5.83 electron volts. So it's a stable configuration, and then we let this combined system interact with the same three molecules. For example, in the case of the hydrogen molecule, we have a significant increasing energy, absorption energy of minus 0.25 electron volts, which still could be considered as adsorption. The largest increase is found in the second case for the carbon monoxide, in which we have the final absorption energy of minus 1.41 electron volt, and this could be considered in general as chemisorption. As you can see here, the carbon atom is the one interacting with the platinum. And finally, we have a not so large increase in the adsorption energy for carbon dioxide. Here is the energy, minus 0.27. So the conclusion is that the platinum has a rather large chemisorption effect, and it could then be studied what would be the effects in the band structure or the optical properties of the combined system, so as to see if this could be used in sensor technologies, for example. Well, if you check the poster, you can see here the references as well, and I hope you enjoyed it. If you have any doubts, feel free to contact us in my email. And on behalf of the rest of the authors, I thank you, everyone that will see this recording sometime in the future. Thank you.